let's just talk about the Euclid's 5 important postulates. Let's just start with the Euclid's very first postulate, which says that a straight line may be drawn from any one point to any other point. So definitely note that from this particular postulate, it actually says that there exists at least one line. There exists at least one line which joins the two distinct points. There exists at least one line. There exists at least one line which joins two distinct point. So as per this postulate, we can say that it says that there exists at least one line which join two distinct points. Obviously, it does not say that there exists only one line which can pass through two distinct points, or there cannot be more than one line which can pass through two distinct lines. But Euclid, in his work, he actually assumed that there exists only one such line or unique line that passes through two distinct points. So he justifies this thing into his axiom. So let's just see his axiom. So let's just talk about the axiom related to the postulate 1. The axiom is, given two distinct points and there is a unique line that passes through them. So for an instance, I'm talking about the two distinct points as nothing but point P and as nothing but point Q. So let us suppose if I'm saying that how many lines can pass from the point P that also can pass through the point Q. So obviously, if I'm talking about a line which can pass through P as well as which can pass through Q is nothing but only one. As you can see over here, there is only one line that can pass from one only line, or we can say one line only. There is only one line that can pass through. There is only one line that can pass through the point P, which can also pass through the point Q. And moreover, if I am talking about the vice versa condition, that how many lines you can draw from the point Q that also passes through the point P. So obviously, this is nothing but that unique line which is passing through these two distinct lines in a unique way. So it means that this axiom is actually self-evident and it need not to be proved. So this is all about the postulate 1 of Euclid. Now let's just talk about the Euclid's second postulate, which says that a terminated line can be produced indefinitely. So a terminated line, what is the meaning of a terminated line? So in the Euclid's definition, it is a terminated line, but nowadays we call it as nothing but a line segment. So note that a terminated line is nowadays called as nothing but a terminated line. In the Euclid's definition, is nowadays called as a line segment. It is called as a line segment. So we are linking the Euclid's definition now with the line segment. So as per the Euclid's terminated, he used the line as nothing but the terminated, but nowadays it is called as a line segment. So he says a terminated line can be produced indefinitely. So it means, let us suppose if I'm talking about these two particular points and I am joining these 2 points as this. So this is definitely nothing but a line segment which is called as a terminated line. So if I'm talking about nowadays how I can pronounce this particular postulate, that if this is nothing but a particular line segment, then I can extend it. Then I can extend this particular line segment into both sides in an indefinite manner. So if I am talking about the definition of this in nowadays form, then I can say that for any particular line segment AB, I can extend this line segment to both sides in an indefinite manner. So this is nothing but the postulate 2 of Euclid's. So let's just see the next further postulate of Euclid. So the postulate third is a circle can be drawn with any center and any radius. Further, the postulate 4 says that all right angles are equal to one another. And the fifth postulate, which is actually an important one, says that if a straight line falling on the two straight line makes the interior angles on the same side of it, then together less than two right angles, then two straight lines, if produced indefinitely, meet on that side on which sum of the angles is less than two right angles. So let us suppose if I'll convert this particular postulate into the figure, then I can say that if a straight line falling on the two straight line means, first of all, let us suppose if I'm drawing this particular line, let us suppose, and I am calling this line as L, and further let us suppose if I'm drawing another straight line, let us suppose if I'm drawing another straight line as this, and I'm calling it as nothing but M. So there exists a straight line which is falling on these two straight lines. So let us suppose I'm drawing another straight line over here. Let us suppose this one is the straight line, and let us suppose if I'm calling it as nothing but N. So according to the postulate, it says that if a straight line falls on the two straight lines, makes the interior angles on the same side of it. So let us suppose if I'm talking about making the angles on the same side, let us suppose this is nothing but the point P, and let us suppose this is nothing but the point Q. So basically we are talking about this particular angle. Let us suppose I'm calling it as angle 1, and let us suppose I'm calling this as angle 2. So it says that the interior angles on the same side. So let us suppose if I'm talking about the left side of P, I'm talking about the left side of the P. It says that the interior angles of the same side of it together means angle 1 plus angle 2 is less than two right angles. Two right angles means 2 into 90 degree. So according to this condition, it says angle 1 plus angle 2 is less than 180 degree. So whenever such a condition can occur, then the two straight line means the line L and the line M, if produced indefinitely, if you can produce it in an indefinite manner, let us suppose if I'm producing it into an indefinite manner over here as well as over here, if I'm producing them indefinitely, then it says further, if produced indefinitely, meet on that side, because we are talking about only the left side, meet on that side, they can meet on this particular side on which the sum of the angles is less than two right angles. So this is nothing but the postulate 5, which says that if we have a straight line which is falling on the two straight lines and makes the interior angles on the same side of it together less than 180 degree, then the two straight lines, when produced in an indefinite manner, will coincide with each other, or we cannot say coincide, will intersect each other on that particular side where the sum of the angles is less than two right angles. So this is nothing but the postulate 5 of Euclid. So as we are done with the Euclid 5 postulate, let's just recall all the postulates again. So postulate 1, 2, 3 and 4. These 4 postulates are actually quite simple, and that's why they are called as nothing but the self-evident truths that need not to be proved further. But the 5th postulate is actually quite a complex one that definitely requires some justification. But further, if I'll say that nowadays postulates and axioms, they are terms that are used in the same sense, because if we are connecting Euclid's postulates and axioms with our life nowadays, then we can say that the postulates and axioms are nowadays, they are taken in the same sense, where postulate is considered as nothing but a verb. And further, the truth and the validity, its truth and the validity is checked afterwards. So if it is true, then it is accepted as a postulate. So it is quite an important concept that nowadays postulate and axioms are used, the term, or they are the terms that are used in the same sense, and their truth and their truth or the validity is checked afterwards, and if it is true, then it is accepted as nothing but the postulate. So if we are talking about the consistent system, what is the meaning of that? A system of axiom is called consistent if it is impossible to deduce from the axioms a statement that contradict any axiom or previously proved statement. So always remember what is the meaning of consistent. A system of axioms is called as consistent if it is impossible to deduce from the axioms a particular statement that contradict any particular axiom or previously proved systems or the previously proved statements. This is nothing but called as consistent. And further, there is a special note: when a system of axiom is given, it need to be ensured that the system is consistent or not. So whenever we have any system of axiom which is given to us, it need to be ensured that whether the system is consistent or not. So let's just talk about the new concept, which is nothing but called as propositions. What is the meaning of propositions? So obviously Euclid have used his postulates and axioms, or he defined his postulate and axioms, and further he used these postulate and axioms to deduct some results. So he used his postulate and axiom to find out some of the particular results, and further he used these results to get some other results or more results from the deductive reasoning, So if we are talking about this particular process, then we can say that the statement that were proved are called as the propositions or the theorems. So Euclid, when he discovered his postulates and axioms, he used them to find out the results of the statement, and further used those results to find out the results or find out more results through the deductive reasoning. So all these statements or the statements that were proved at the end, they are nothing but called as the propositions or the theorems. They are called as proposition or theorems. So Euclid deduced 465 proposition in a logical chain. In a logical chain, he just deduced 465 proposition using his axiom, using his definition, and using his postulates, and the theorems were actually proved earlier in this particular chain. So let's just now use the axioms and the postulates of the Euclids in some of the question, that how we can use the Euclid's axiom and postulate in finding out the solution set of the question. So let's just see some of the questions.